Hello everyone, welcome to this MONBUKAGAKUSHO solution video, and in this video I will discuss to you about the 2015 chemistry paper. So this is the paper for 2015 chemistry. Obviously this is for undergraduate students, and yep. So in this video it's part 1. Let me discuss about part 1, because in chemistry there are 7 parts, which is lots of question out there, but let's discuss the solution. Okay, so number 1, which of the atoms and ions 1 to 4 has the different electron configuration from those of the others? So it is discussed about electron configuration, so let's write it. So first is we discuss part 1 and about the electron configuration. First we write F minus. There are neon, then the sodium ion, then the argon. Okay, so the way that I want to write the electron configuration is what I used to write to draw it is actually using the Aufbau configuration. Now the Aufbau configuration actually looks like this. For example, we have a carbon which has 6 atoms. I just put it with the maximum number in the electron shell. What I mean is, for example, the shell in the atom, we used to write it as the shell K, shell M, shell M. So let's say this is a nucleus. So this is shell K, this is shell N, L. And the maximum number for the electron inside one shell is actually 2n squared. And this n is filled with what is the number of shells. So K is the shell number 1. So the maximum of electron in shell K is 2 times 1 squared, which is 2. So since there are 6 electrons, so first is 2, and another electron should be in the second shell, right? So in the shell L, the maximum number of electrons is 2 times 2 squared, is 8. But since we have already inserted 2, we need 4 of the electrons. So we put it 2 and 4. So that's what happened. Same as to go when we apply that to F ion, the fluorine ion. So because fluorine have 9 electrons, but because it has a negative ion, meaning that the electron is +1, so it will be 10. So for 10, so it should be 2 in the first shell, the maximum electron, then 8 in the second shell. So that is 10. And for neon, it is 10 in the noble gas. It's also the same. And for the sodium ion, sodium is 11. If you see in the periodic table, just this one, you can see that this is the atomic number 11, which is same as the electron number. But since we have a plus ion, so we have 10. From 11 we plus, but it is less the electron, so it is 8. And the last is argon. You can see that argon in noble gas, it's actually 18. And 18 is actually 288. How we got the number 8? Because the first electron, the maximum is 2. The second shell, the maximum of electron is 8. And the third electron, let's say that is M, is actually 18. But we only have 8 left, so we put 8 here. So the only atom that is different in its electron configuration is argon. So the answer for number 1 is argon. So let's go for number 2. So this is number 1, and let's go for number 2. So for number 2, it says that which of the acid aqueous solution from 1 to 4 is a non-volatile. So what is non-volatile? Non-volatile is actually the tendency for a molecule or an atom or a compound tendency to not easily evaporate. Right? So what it means that from the compound that is present, first that is acetic acid, then hydrogen sulfate, then the hydrochloric acid, and the hydrogen fluoride. The ones that not easily evaporate is actually the strong acid, and this acetic acid and hydrogen fluoride is actually weak acid. So we have two final choices, which is strong acid, not easily evaporate. And to make it easier, the not easily evaporate is actually the much stronger acid, and the answer is hydrogen sulfate. Because if we make it into ions, it resulted in 2H plus and the sulfate ion. We separate this to ions, it becomes Cl minus ion. You can see that the H plus ion, the one that make it acid, is more of the H plus ions in the hydrochloric acid. So the way that hydrogen sulfate is more acid, stronger acid than hydrochloric acid. So the tendency to not easily evaporate, or the most non-volatile compound in this solution is hydrogen sulfate. So the answer is 2, the number 2, hydrogen sulfate. Then for number 3. Now number 3 says that which of the substance is a triple bond. So it's just a regular structure. Let me write it. So for number 3, the first is hydrochloric acid. So what the structure of hydrochloric acid looks like, we know that H has one valence electron, and Cl has 7 valence electrons, but it just bonded to 1, so it is actually a single bond. Number 2 is actually sulfuric acid. We know that sulfuric acid is H2SO4. Well, actually, I said it hydrogen sulfate, but maybe it's the same. But the sulfuric acid is H2SO4. Now the way to draw H2SO4 is a bit different. So we know that S, sulfur, has 16 electrons, thereby has 6 valence electron, and we know that O is actually have the same valence electron as sulfur, 6, and H has only 1. And the way that it's drawn is actually S has 6 valence electron, we divide it into that, and for O it has 6 valence electron, right? And another O has 6 valence electron. Then we have 4 O's, which is a lot. You can see that I draw it a little bit small just to make it easy to see. And H, finally. You can see that this is H2SO4. So when we conclude that to a good Lewis structure, as double bonded to one oxygen, another oxygen, and single bond to here, and remember to put in the valence electron, the lone pair, then H. You can see that this is only double bond and single bond, thereby it is not triple bond. Then look at the third option, which is cyanic acid. Do you know what is cyanic acid? It's actually HCN. Then C has 4 valence electron, while H has 1. So we can make that a single bond. And with that nitrogen actually has 5 valence electrons, and the 3 of it is triple bonded to the carbon and has 1 lone pair. So this is a triple bond, and thereby this is the answer. And if you wonder, the fourth option is actually a formic acid. Formic acid is actually HCOOH, right? So the way that this is bonded with each other is actually H, C, O and OH. So this is actually RCOH is an aldehyde, but it has not triple bond. It only have double bond and single bond. So the answer is 3. Cyanic acid has a triple bond structure. And now for number 4. Number 4 is quite easy. It says that which of the substance of fluorine, chlorine, bromine, and iodine is a liquid under atmospheric pressure at 25 degrees Celsius. So you probably have known this if you look at the periodic table. So this is actually my version of periodic table. Look at this FCl, bromine, iodine, and astatine. It's actually halogen, right? So in my periodic table, it says that the green shows that it is gas, blue is liquid, so the answer is bromine. And for iodine and astatine, this is a radioactive element, but in yellow, in my periodic table, it says that it is solid. So the answer is bromine. So number 4, we had fluorine, chlorine, bromine, and iodine is this one, which is liquid. So the answer is bromine. Then for the 5th number, it's actually quite intricate for this 5th number. It says that which of the description 1 to 4 not correct for the properties of sodium. Okay, so it says that the unit cell of crystalline sodium has a cubic shape. Number 2, sodium metal is chemically stable in an ambient atmosphere. Do you know what is ambient? Well, I looked at the internet. It says that ambient is actually room temperature. So it is a state where it is at the normal condition. And the reaction with alcohol produces hydrogen. So the example of reaction between sodium and hydrogen and alcohol. So let's say we want to react it with methanol, right? For example, nitrogen and methanol. Well, in this particular reaction, we can actually separate this into CH3O minus for the ion and for H plus. Then for the sodium is actually positive ion, so we can combine this to CH3ONa and H, although the H is alone, since we have this is 4 and this is 3, so this is lacking one more H, this is hydrogen. And to balance this equation, so it is actually true, reaction with alcohol produces hydrogen, so this is correct. And using flame test, sodium shows a bright yellow color. Well, actually, by looking at this option, if we didn't actually know how will sodium react when it is flaming, we can actually look at the other option. What I mean is, look at number 2. Sodium metal is chemically stable in ambient atmosphere. Well, it's actually not true, because sodium ion, in its valence electron, sodium has 1 valence electron. So it is actually chemically unstable, meaning that sodium has a much more reactivity to the fact that it has only 1 valence electron, meaning that it is easily react to actually release its electron. So the one which is not correct is actually number 2. Sodium metal is chemically unstable in an ambient atmosphere. So let's look at 4 other numbers for part 1. Oh, it's actually another one. Number 6 is actually a type of reaction. So it is said that which combination of substance will not produce ammonia under appropriate temperature and pressure condition? Well, we just write the reaction. So number 1, the option 1 for that is actually copper reacted with concentrated nitric acid. Remember that nitric acid is HNO3. Well, this reaction tend to be this way. So they are called copper nitrate, then nitrogen dioxide, and H2O. See, in this reaction there's no ammonia, so this is not the answer. Number 2 is actually nitrogen and hydrogen. Well, this is in this reaction nitrogen plus 3 hydrogen equals 2 NH3. So the way I write the reaction, I already write the balance form, so it is easier for you to understand that it is produced ammonia. So, I think the question says that will not produce ammonia. I think the answer is 1, so let's look at other option. But it produced ammonia in reaction of nitrogen and hydrogen, so it is not the answer. And then the third one option is urea and water. And do you know the formula compound for urea? For urea is actually, this is the compound formula, and water is actually reacted to NH3 and COOH. So it produces ammonia. And number 4 is actually calcium hydroxide, this, and ammonium chloride. You can see that in the reaction it will result in this, so it still produces ammonia. So therefore the answer is number 1. Copper and concentrated nitric acid didn't produce ammonia. Then for the last number is number 7. Which of this description is appropriate for the phase diagram of pure substance? So do you know what is phase diagram of pure substance? Well, it is actually in the topic of colligative properties, where it is a diagram of pressure and temperature. So this is the diagram I draw. Well, you see that it is not in English language, it is actually Indonesia language. Well, I'm actually an Indonesian, okay, but I am good at my English, so I put at this diagram. Anyway, let me translate it to you. This is a diagram of pressure. This is pressure. This is temperature, okay, and this is 1 atmosphere. And if you see it, this is actually a vapor pressure. For the ones of you who didn't understand Indonesian language, it is a vapor pressure. This is solid, so this is the Indonesian language for solid. This area is liquid, this is gas. This point C is triple point, right? And look, this is TB1 is actually the boiling point of solution. TB0 is a boiling point for the solvent. TF1 is the freezing point of solution. TF0 is the freezing point of solvent. This CD is the line of water boiling point. BG is actually the boiling point line for the solution. CE is the freezing point of water. BF is the freezing point of solution. B is the triple point. Triple point means it is the point where the type of water coexist in 3 types of status. So the water here could be solid, could be liquid, could be gas. So it is a unique point. A is the initial temperature. C is the triple point for the solution. Okay, so it's actually the triple point. What I could say is actually the equilibrium phase between liquid, gas, and solid. So let's look at the question. It says that the slope of the gas-solid boundary is negative. If you look at it, gas and solid is actually with this one. So it is not negative, right? It is positive. So therefore this is wrong. And number 2, it says that the gas-liquid boundary extends infinitely towards higher temperature and pressure. We said gas and liquid here. Well, it is actually not infinite. It is actually bounded by the certain measure of pressure. It is not infinite. So this is wrong. And for number 3, says that the solid liquid boundary of water is positive. So you see that solid liquid, is this positive? No, it is actually negative. So this is wrong. Lastly, at triple point, 3 phases coexist at specified temperature and pressure, and this is right. Because as I say that at triple point, there is an equilibrium phase between solid, liquid, and gas at the specified temperature and pressure. You see that this triple point is actually at some pressure here, but it's actually at something that is specified. So therefore, the description that is appropriate for the phase diagram of pure substance is that this. At triple point, 3 phases coexist at the specified temperature and pressure. So that's it, everyone, for our discussion for part 1 of MONBUKAGAKUSHO Chemistry 2016. And stay tuned for this part 2. And yep, for the next video would be part 2 of Chemistry 2015.